Okay, so we're going to take a look at inheritance from a slightly different standpoint than we did in the last unit. Sometimes we want to use inheritance just to kind of factor out common code. So in this case, you'll see that I'm trying to make a predator critter. This will be a critter that eats other critters. And then I'm going to make a vegetarian critter. This is a critter that eats only other flowers. Both of them also have a unit of energy, so when they eat, they're going to increase their energy, and if their energy gets too low, they're going to be removed from the grid. They also have behavior based on sleep. Their behaviors are similar, but their behaviors are not exactly the same. We can see that their process actors methods are very, very similar. Select move locations is going to be the same. If the sleep state is too high, then we're going to return the same location. If the energy is too low, then we're going to return null. Otherwise, return super.select move location. So this code is exactly the same. Then make move will also be very similar. And then the predator, actually both of these, if they end up staying in the same spot, then we're going to call this method called the sleep method. So both vegetarian and predator critters have a method called the sleep method, which we're going to refer to later. Okay, so clearly there's a lot of code that's common between these two things, so we should use inheritance to try to factor out the common code. Okay, so what we want to do is grab all the common code and put it in a common superclass. And so the idea here is we're going to grab all the code that is common to both of these things. The abstract energy critter will extend critter, and then the other two are going to extend abstract energy critter. So we have all these instance variables. Now process actors is going to be different every single time, so we're going to delete this. Those will be implemented just by the individual classes. Select move location is exactly the same for both of them. Make move, you can also see, is totally identical in predator critter as it is with vegetarian critter, so we should leave that in the common superclass as well. Now notice that the make move method is completely the same between vegetarian critter and predator critter, but the sleep method is totally different. So I would have to delete the sleep method. Now we have a problem. If I try to compile abstract energy critter, it's going to say, hey, I don't see any sleep method. So this is a problem. I want to save all the code from make move because it's identical between both of the classes, but the make move method requires that there exist a sleep method. But I can't write the sleep method because it's different for each of the two classes. This is where abstract methods come in really handy. What we do in this case is we say, look, I have to have a sleep method, but I just won't code it yet. So just like in an interface, I say public void sleep, but I can't code it, so I declare this method as abstract. Now what this means is, just like an interface, all subclasses of abstract energy critter will have a sleep method, because if I call sleep, Java sees that there is a sleep method, and all this does is guarantee that subclasses of this class have a sleep method that takes no parameters and returns void. But they can implement that method any way that they want. So a predator critter will sleep the way that they want, and a vegetarian critter can sleep the way that they want. Everything else is inherited as is. Anytime you have any abstract method, you have to declare the whole class as abstract. An abstract class cannot generate objects. So I'll never be able to create an abstract energy critter object. I'll only be able to create objects from its subclasses. Let's get that compiler error that we want. There we go. Notice what it says down here. Abstract energy critter is not abstract and does not override abstract method sleep in abstract energy critter. So what they're saying is this class has an abstract method. That means we can't create objects from it because there's no definition for how this class should behave. Therefore, we have to declare the entire class abstract. And this is a general rule, and this is one of the rules you have to know for your tests and quizzes. If a class has any abstract methods in it at all, then the entire class must be declared abstract. So abstract classes really are just kind of a repository for code, and they belong in the middle or towards the top of an inheritance hierarchy. So that works. Now let's go back in here. Let's have vegetarian critter rather than extending critter, and now we don't need these. Process actors we need to code. Select move locations, however, we are inheriting. Now watch what happens if I hit compile. It compiles. Or to comment out the sleep method and try to compile, it would say vegetarian critter is not abstract and does not override abstract method sleep in abstract energy critter. In other words, we're trying to say we want to be a subclass of abstract energy critter. In order to do that, we need to have a fully defined sleep method. So we have to code the sleep method. We can go into predator critter and again delete all of the code, and because I have a sleep method, it's letting me compile. If I again comment all those out and hit compile, the abstract class is not letting me finish this because I don't have a sleep method.